Alright, this is Ken Roserer. We're going to talk about probabilities of draws without replacement. So for these, the formula we're going to use, the overall formula is probability equals number of desired outcomes out of number of possible outcomes, also known as the sample space, the number of possible outcomes. And here's our sample problem. We're going to do a few of these. A history class is comprised of 3 female and 8 male students. If the instructor of the class randomly chooses 5 from the class for an oral exam, what is the probability that 2 female and 3 male students will be selected? And we're going to round our answer. Okay, so we have 11 students. We are choosing 5. That's the size of our sample space. It's 11 choose 5. So if you want, you can calculate this off to the side. 11 divided by 6, 5. Remember, this number here is always 11 minus 5 because it's n minus r. Okay? If you forget the formula, here I'll show it to you real quick and then we'll do it again. So the formula for combinations, when we're choosing r out of n, it is n factorial divided by r, n minus r, in parentheses factorial, times r factorial. And the rationale is these guys figure out the number of ways that you can choose, and this one here takes out all the repeats. But that's in a different video. Anyways, you just need to know to use this, and it's 11 choosing 5. It's going to be 11 factorial over 6 factorial times 5 factorial, which we know is going to be, let me erase some of this, it's going to be what? It's going to be 11 times 10 times 9 times 8 times 7 times 6 factorial over 6 factorial times 5 factorial. That kills that. 5 factorial is 5 times 4 times 3 times 2. So 4 times 2 takes out the 8. 5 goes in 10, leaving 2. 3 goes into 9, leaving 3. Okay, so that is the denominator. It is 11 times 2 times 3 times 7. And you don't have to calculate that because we'll have more cancellation. In the numerator, we want to choose 2 females out of a possible 3. So 3 choose 2. That's for the females. For the males, we have 8 males, and we're going to choose 3. So using the formula, we have 3 factorial over 1 factorial times 2 factorial. And hopefully you'll figure out after a while that whenever these differ by 1, the answer is n. Okay, so that comes out to 3. And then what do we have over here? We have 8 factorial. And that's 5 factorial, and that's 3 factorial. Now you could go like this. And then 2 goes into, well, you can't go 2 goes into 8 because you got to write this out. So we'll rewrite this as 8 times 7 times 6 times 5 factorial. 5 takes out 5. And then 2 goes into 6 3 times. So in the numerator, I have 8 times 7 times 3. The 3 and the 3 go away, the 7 and the 7, and I'm left with, and the 2 goes into the 8 4 times, so I'm left with 4 over 11. And that is my probability of, what is it, 2 females and 3 males. Now let's do another one. An urn contains 4 green and 3 white, so we have 7 balls. And how many are we going to choose? 5 balls at random. So 7 choose 5, so it's It's going to be 7 times 6 divided by 2. And you can do the math on that to confirm that it's 21. I use the formula and make sure you understand how I got that. So that'll be the sample space, the number of possible outcomes, and now we need to figure out the favorable ones. We want to know what is the probability that choosing 5, he will select 3 green and 2 white. So 3 green out of 4. So that's 4 choose 3 times, and then 3 choose 2. So this is for the green, this is for the white, and I just told you a second ago, when these guys differ by 1, the answer is always n. So it's 4, it's 3, so we have 4 times 3 over 21, which goes in 7, so our answer is 4 over 7. It's the probability of 3 green and 2 white. Alright, hopefully you're getting the hang of this. Let's do another one. History class, 9 females, 10 males. So our sample space is 19, and we're choosing 6. So it's 19 choose 6. So it's going to be 19 factorial divided by 13 factorial times 6 factorial. So that's going to be 19 times 18 times 17 times 16 times 15 times 14. The 13 factorial that would come after that will cancel with the 13 factorial on the bottom. And so then we have 6 times 5 times 4 times 3 times 2. All right, 4 times 3 is 12. No, what do I want? Let's do 3 and 6. Take out the 18. 4 and 2 go into there and leave a 2. 5 goes into 15 3 times. So that's my denominator. Now they want to know what is the probability that 4 female students are chosen. So 4 out of 9 are chosen, and 2 males out of 10. So 10 choose 2. So our numerator is going to be 9 choose 4 is going to be 9 over 5, 4 times 10 over 8, and then 2. And this one's pretty easy. It's going to be 9 times 8 times 7 times 6 over 4 times 3 times 2 times 10 times 9 over 2. Take a moment and confirm that. Again, what I'm doing is I'm always in my head or on my paper, I'm bringing that out to the 5 factorial, because that once I get to 5 I can cancel, and then the 4 I just expanded. Okay, and as you get to know these, you can do it a lot quicker. So what I'm going to do is I'm going to take this 3 and this 2 and cancel that 6, this 4 and this 2 and cancel that 8. So what do I have? I have 10 times 9 times 9 times 7 over 19 times 17 times 14 times 3 times 2. Alright. That is for my P of 4 females and 2 males. And of course you'd have to simplify this. I'm going to skip that step though. You guys can simplify on your own. Alright, we'll do one last one and then we'll call it quits. Here we go. A history class. Oh my gosh, is this the same problem? It looks like it is. So I guess we're done. And I hope that's helpful. Probability is the number of favorable outcomes divided by the number of possible outcomes. Bye-bye.